Let's take a look again at the HALD data. Remember, in HALD data, we have 13 data points. P equals 4 variables here. And the fifth one is y. And we simply say, well, this is regression. Yi's are normal with mu I and tau precision. And this mu I is intercept and plus inner product between betas, vector of betas, and the x's. But these x's are here standardized. For these x's, we subtract the mean and divide by standard deviation. So we put them on the same footage, and that helps when you do this, this type of variable selection. Then you say that these betas here are some alphas times the indicators. The indicators are Bernoulli, and I put here a priori that I don't have preference if the variable is in the model or not. So a priori, the Bernoulli is 1 with probability 50%, 0.5, and 0 with probability 0.5. So it has equal chances to be in or out of the model. And then alpha is the part of the coefficient. That one is given some prior. In experiment, you don't want to put too non-informative. So here is slightly non-informative with precision 0.1. You run the model and you save delta. And you see that in this case, delta 1, first variable, was 1 99.9% of the time. Delta 2 was 1 93.32% of the time. But delta 3 was not in the model often, less than 50%. And delta 4, corresponding to the fourth variable, was in the model 95% of the time. Now that gives you a count for each variable separately, but it does not tell you in what combinations they went into the model. So let's go back to the model here and take a look at this. I index all models with 4 different indices, J1 up to J4, depending if this variable is in the model, which is meaning 2, or not in the model, which is 1. So for example, if I have indexing 2, 1, 2, 1, that indicates that intercept is always in the model, 2 for 1. For x2, I have 1, so not in the model. For x3, I have 2, that one is in the model. And for x4, I have 1, it is not in the model. So this 2, 1, 2, 1 is model, which is intercept plus first variable plus third variable. If I do that, then I may check how many times I visit this model J1, J2, J3, J4. And that one is how many times I get delta 1 being 1. At the same time, how many times I get delta 2 to be 1, delta 3 to be 1, delta 4 to be 1 for these j's being 2. But if j1 is equal to 1, that one is not in the model. Essentially, this product models simultaneous appearance of the model indexed by J1, J2, J3, J4. Take a look how many times MC visited these models. For example, only intercept was never visited, almost. The most visited model here looks to be this one, with 51% of all visits. And that model is intercept plus x1 plus x2 and plus x4. So that model is there. The other models are also quite visited. For example, model that has all variables was visited 37% of the time. And also, for example, 5% of the time, model 2122 was visited. But all other models are essentially less than 5% time visited. So that is interesting way how you do model selection by so-called stochastic search variable selection.